Hello and welcome. Today, we're diving into the world of cloud data platforms. We'll be comparing four major players: Snowflake, Databricks, Azure Synapse, and AWS Redshift. Choosing the right platform can make or break your data strategy, so whether you're a data engineer, analyst, or business decision maker, this video is for you. Let's get started. Platform overviews. Snowflake. Snowflake is a cloud-native data warehouse that's been making waves in the industry. It's unique in its separation of storage and compute, allowing for incredible scalability. Imagine you're planning a big party. With Snowflake, it's like being able to instantly expand your venue, storage, and add more staff, compute, as more guests RSVP, without any disruption to the party planning already in progress. Databricks. Databricks, built on Apache Spark, is a unified analytics platform that excels in big data processing and machine learning. Think of Databricks as a Swiss Army knife for data scientists and engineers. Need to process terabytes of data? Check. Want to train a machine learning model? No problem. Prefer coding in Python, R, or Scala? Databricks has got you covered. Azure Synapse. Azure Synapse is Microsoft's integrated analytics service. It's like having a one-stop shop for all your data needs within the Azure ecosystem. Imagine you're cooking a complex meal. Azure Synapse is like having all your ingredients, utensils, and appliances in one perfectly organized kitchen. It brings together data integration, warehousing, and big data analytics in a seamless environment. AWS Redshift. Amazon's Redshift is a fully managed data warehouse designed for high performance at scale. It's deeply integrated with the AWS ecosystem. Picture Redshift as a high-speed train network for your data. It's optimized for moving and analyzing large amounts of data quickly, and it connects seamlessly with other AWS services like S3, Glue, and QuickSight. Key feature comparison. Architecture and scalability. Let's compare how these platforms handle growing data needs. Snowflake uses a multi-cluster, shared data architecture. It's like having multiple teams working on the same project, able to scale independently without stepping on each other's toes. Databricks leverages Spark's distributed computing. Imagine a massive parallel processing machine, able to break down complex tasks into smaller, manageable pieces. Azure Synapse combines serverless and dedicated resources. It's like having both on-demand workers and a permanent staff, giving you flexibility and power. Redshift uses MPP, massively parallel processing, architecture. Think of it as an assembly line for data, where multiple workers process data simultaneously. Performance. When it comes to query performance, Snowflake shines with its ability to cache query results, speeding up repeated queries dramatically. Databricks excels in processing large, complex datasets. Its Photon engine can significantly speed up SQL queries. Azure Synapse offers intelligent workload management, automatically optimizing query performance based on workload patterns. Redshift uses columnar storage and zone maps to speed up queries, particularly for data warehouse workloads. For example, in a recent benchmark, Snowflake processed a complex join operation on a 1 terabyte dataset in under 10 seconds, while a traditional data warehouse took over a minute. Data integration and ETL. All four platforms offer robust ETL capabilities, but they approach it differently. Snowflake's Snowpipe offers continuous, serverless ingestion of data. Databricks has Delta Live tables for building reliable data pipelines. Azure Synapse integrates tightly with Azure Data Factory for ETL workflows. Redshift works seamlessly with AWS Glue for ETL jobs. For instance, you could use Snowpipe to automatically ingest and process log data as it's generated, ensuring your analytics are always up to date. Security and compliance. Security is paramount in all four platforms. Snowflake offers end-to-end encryption and secure data sharing. Databricks provides fine-grained access controls and ACID transactions. Azure Synapse leverages Azure's robust security features, including Azure Active Directory integration. Redshift offers column-level access control and integrates with AWS security services. All four are compliant with major standards like HIPAA, GDPR, and SOC 2. Pricing models. Pricing can be complex, but here's a simplified view. Snowflake charges separately for storage and compute with per-second billing. Databricks uses a mix of DBU, Databricks unit, consumption, and instance costs. Azure Synapse has serverless and dedicated options with pay-as-you-go or reserved capacity pricing. Redshift offers on-demand, reserved instance, and serverless pricing options. For example, a small data warehousing workload might cost around $200 per month on Snowflake, while a similar workload on Redshift could be around $180 per month with reserved instances. Ease of use and management. User-friendliness varies. Snowflake is known for its intuitive interface and minimal need for optimization. Databricks offers a collaborative notebook interface, great for data science teams. Azure Synapse provides a unified interface for various analytics tasks. Redshift requires more hands-on management, but offers powerful tools for query optimization. Some pros and cons for each data platform. Snowflake. Some pros. Exceptional scalability. Snowflake's architecture allows for instant, independent scaling of compute and storage. Example, a retail company during Black Friday can instantly scale up its compute resources to handle the surge in data analytics requests without any downtime or performance degradation. Ease of use, minimal setup and maintenance required, with automatic optimization. Example, a startup with a small IT team was able to set up and start using Snowflake for their data warehousing needs within days, without hiring additional database administrators. Data sharing. Seamless and secure data sharing between Snowflake accounts. Example, a healthcare research institution easily shares anonymized patient data with partner organizations for collaborative studies, maintaining strict access controls. Cons for Snowflake. Potential costs. While flexible, costs can escalate quickly with heavy usage. Example, a media company found their Snowflake bills increasing rapidly as their data scientists ran increasingly complex queries, requiring careful monitoring and optimization of query patterns. Limited control, less granular control over the underlying infrastructure. Example, a financial services company with specific compliance requirements found it challenging to meet certain regulatory demands due to the lack of low-level access to the database engine. Databricks. Pros. Powerful for big data and ML, excels in processing large datasets and implementing machine learning models. Example, an e-commerce giant uses Databricks to process terabytes of customer interaction data daily, feeding it into ML models to personalize user experiences in real time. Language flexibility. Supports multiple programming languages, SQL, Python, R, Scala. Example, a data science team with diverse skills collaborates efficiently on Databricks, with some members using R for statistical analysis, others using Python for ML, and data engineers using SQL for data prep. Unified platform combines data engineering, science, and analytics in one place. Example, a telecommunications company uses Databricks as a central platform where data engineers prepare data scientists develop ML models, and analysts create business intelligence reports, all within the same environment. Cons. Complexity can be overwhelming for simple data warehousing tasks. Example, a small marketing agency found Databricks too complex for their straightforward reporting needs, requiring more time and expertise than anticipated. Learning curve. Steeper learning curve, especially for those new to Spark. Example, a team of SQL proficient analysts struggled initially to adapt to Databricks' Spark-based environment, requiring additional training and ramp-up time. Azure Synapse. Pros. Integrated analytics. Combines data integration, warehousing, and big data analytics. Example, a manufacturing company uses Synapse to ingest IoT sensor data, stored in a data warehouse, and perform predictive maintenance analytics, all within a single platform. Azure Ecosystem Integration, seamless integration with other Azure services. Example, a financial services firm easily connects Synapse with Azure Machine Learning for fraud detection and Power BI for executive dashboards, creating an end-to-end analytics solution. flexible pricing, options for serverless and dedicated resources. Example, a startup uses serverless SQL pools for ad hoc queries to minimize costs, while maintaining a small dedicated SQL pool for consistent workloads. Cons. Azure lock-in. Deep integration with Azure can make it challenging to migrate to other cloud providers. Example, a company considering a multi-cloud strategy found it difficult to partially migrate their Synapse-based analytics stack to AWS without significant re-architecting. Complexity for non-Azure users can be complex for organizations not familiar with the Azure ecosystem. Example, a team primarily experienced with AWS services faced a steep learning curve when adopting Synapse, requiring additional training and adjustment period. AWS Redshift. Pros. Performance. Excellent query performance for data warehousing workloads. Example, a large retailer uses Redshift to analyze billions of customer transactions, generating reports in seconds that previously took hours. AWS integration. Deep integration with the AWS ecosystem. Example, a media streaming service seamlessly moves data from S3 to Redshift for analytics, uses AWS Glue for ETL, and QuickSight for visualization, all working together smoothly. Mature ecosystem, well established with a wide range of tools and community support. Example, a software company quickly found third-party tools and numerous online resources to help optimize their Redshift deployment and troubleshoot issues. Cons. Management overhead requires more hands-on management and optimization. Example, a company needed to dedicate a database administrator to continually monitor and optimize Redshift performance, adjusting distribution keys and sort keys as their data patterns changed. Less flexible scaling. Scaling can involve some downtime and manual intervention. Example, an e-commerce company experienced brief interruptions in their analytics capabilities when needing to resize their Redshift cluster during peak shopping seasons. Upfront capacity planning. Most cost-effective with accurate capacity planning, which can be challenging. Example, a growing startup struggled to predict their data warehousing needs accurately, leading to over-provisioning and higher costs initially as they erred on the side of caution with their Redshift deployment. Use cases and recommendations. Choose Snowflake if you need a pure, easy-to-use cloud data warehouse. It's great for companies that want to minimize infrastructure management. Go for Databricks if your focus is on big data analytics and machine learning. It's ideal for data science teams working on complex analytical problems. Azure Synapse is perfect if you're already invested in the Microsoft ecosystem and want an all-in-one analytics solution. Pick AWS Redshift if you're heavily using AWS services and need a high-performance data warehouse tightly integrated with the AWS ecosystem. For example, a retail company dealing with large volumes of transaction data and needing to perform real-time analytics might lean towards Snowflake or Redshift. On the other hand, a research institution working on complex machine learning models might find Databricks more suitable. Conclusion. We've covered a lot of ground today, comparing Snowflake, Databricks, Azure Synapse, and AWS Redshift. Remember, there's no one-size-fits-all solution. Your choice should depend on your specific needs, existing infrastructure, team skills, and long-term goals. I hope this comparison helps you in your decision-making process. If you found this video helpful, please like and subscribe for more content on data and analytics. Thanks for watching.